Right, so as you all know, Artemis 2 is making its re-entry into Earth. Now, I'm going to say this right now at the beginning of the video. I am not an astrophysicist. I will never claim to be an astrophysicist, and I probably will never be an astrophysicist. But now that I got that out of the way, if there is one thing I do truly know, it's re-entry. Okay, so those of you who don't really know what I'm talking about, re-entry is the effect of things that are coming back into the Earth's atmosphere. So this is not just the Artemis spacecraft, but this also includes stuff like satellites and eventually the International Space Station, when it's eventually retired and just ends up running out of fuel. Okay, so look, here's the thing about re-entry. Coming in too fast, you burn up before you even reach lower atmosphere. Until you even reach an atmosphere where you can breathe normally. Although with great difficulty, of course. I'm talking like the atmosphere levels that you probably get on top of a mountain. But come in too slow, you won't even start entry. You will literally just skip. You will bounce right off of the Earth's atmosphere like you are a flat pebble being thrown into a still pond. Like you are a stone being, or in other words, like a stone being skipped across the water. Come in too shallow, you get the same result. Come in too steep, again, you burn up. Come in too slow or too fast, same result. Fast is steep. Coming too fast, you get the same result as steep. Coming too slow, you get the same result as shallow. It is quite literally what you could describe the position that Earth orbits around the sun. The angle to come back into the Earth's atmosphere, it has to basically be it basically has to be the Goldilocks zone. Not too steep, not too shallow, not too fast, not too slow. It's got to be just right. And they cannot get this off by... They cannot be off by a fraction. They are only allowed like a fraction of a millimeter. A measurement so small that it's about the same distance between your blood cells in your body. That is the distance they are allowed. Actually, no, just about the distance, the width of a human hair. That is the allowed deviation that they are... That is a deviation from the perfect angle that they are allowed to have. And they cannot be off of the speed by a single, not even a single mile per hour. They cannot be off at all. Because again, the too fast, you burn up. Too slow, you just bounce off problem. So basically, they have to be very careful. Because these are people inside this capsule. And it makes it so much more difficult. So honestly, for all you astrophysicists and other scientists that work with space and aeronautics, I'm trying to remember what you're called. Aerospace engineers, and all the other big, talented, beautiful minds that go to making these things. You have my honest respect. But just remember, space isn't for everyone. You gotta be ready. You gotta be trained. And most importantly, don't let anyone tell you that going to space is easy. It's not. Thank you for watching my video.